Welcome to InventorCAM Professor. I'm Sydney, your InventorCAM Professor, and this session will be dealing with HSS's option of parallel to surface, and we'll also be putting an emphasis on gouge control. Now, in this part that we see, what I'd like to do is actually mill this surface around here, these surfaces as you see around here, and I want it to be parallel to the surface, to the wall actually, around. Now, the problem over here is that when I pick the surface and I have it go all the way to the end, it will actually gouge into the wall itself. Let's take a look at the operation itself. If I were to open the operation, you'll note the geometry that I picked from parallel to surface. The selected face is this surface around here. And my geometry as far as my edge surface is this surface over here. Now, the tool that I will be using will be a 6mm ball end mill. My levels, I'll leave it exactly the way it was. It's default values. The toolpath path parameters, I'll leave at maximum step of 1mm, and I'll be using spiral cutting method. In my link, I'll be using use lead in and use lead out, and I'll make my gaps long and my links direct. Now let's just save and calculate the way it is right now without doing gouge check. And if we take a look at our simulation and we use the solid verify simulation, you'll see that the tool goes down and around, and when it gets to these walls, because the tool has to get to this, the center of the tool has to get to that corner, it'll actually gouge the wall as you see right here, crashing, taking away the material into the wall itself. Now, the way to avoid this is simply go into gouge check, and first I'll be just checking the drive surfaces from the tool and tip, but with my gouge number 2, I'll actually be driving my check surfaces. Now, my check surface is actually the surface around the wall itself, as shown here. And just to make sure it doesn't touch the wall itself, I've also actually told it to stay away 0.02 of a millimeter. And now, the strategy I'll be using will be leaving out gouging points. In other words, when it gets to the points that it has to gouge, it'll leave it out, and what it'll actually do, it'll actually trim the tool path after that first collision point. In other words, everything after that point will not be there anymore. If I would do now save and calculate, and then simulate the part, you'll note, again, using the solid verify, this time when the tool goes around, when it gets to the wall, it'll actually stop short of the wall. The side of the tool will stop short of the wall, and thereby not gouging into the part at all, as shown here. This is what we call gouge protection for the part. Thank you for joining us on InventorCAM Professor. Take care and have a nice day.